So, welcome back to this section on short term memory, and we basically stopped at the point of what short term memory is in the last section. We discussed the whole idea of what short term memory is. So, in this section we will look into, as promised, into a new conceptualization of short term memory, which is called the working memory. So, let's first look at why this concept of working memory was produced, or it was presented at all. The reason why working memory was presented was the fact that the short term store, as we discussed in the last class, it was basically problematic in many reasons. Now, the short term store, the idea of the short term memory, which is a limited capacity store with 7 plus or minus 2 items as the maximum entitlement of item which is based here, and also for a time duration of 20 seconds, this posed a number of problems. What was it? The first problem that it posed is that this store limits the number of information that I can store here. So, there were limits onto the number of items stored here. Also, in a standard serial position curve, people should not be able to retrieve items in the middle of the list. So, this is how a serial position curves look like. So, this is where the recency effect happens, this is where the primacy happens, and the items in the middle of the list should not show any kind of better recall. And so, this is the on this axis we have the percentage of recall, on this axis this is the serial position of items. So, these are items which is the beginning of the list. So, item number 1, 2, 3 fall here, item. So, if it is a 20 item list, item number 20, 18 and 19 fall here, and so item number 11, 12 are what are present here. So, it was found out that these items, when they were familiar to people, the items when these items when which were familiar to people, or people knew it somehow, they were. So, basically then items which are familiar to people, they should pose a problem to people in terms of remembrance. But what was happening is that the items which were familiar to people, they were showing better remembrance. Also, in terms of interference that we discussed, this interference that we were talking about, items of different codes or different types of items, for example, auditory item and an auditory cue or auditory test item and a visual test item, when they were presented to people in STM, or where people were asked to remember these two items in STM, people were not showing any kind of interference. And so, the fact of the matter was, this STM or the short term memory or the short term store that we are talking about was a little more than the way it was perceived into the Atkinson-Shiffrin model. Now, since we have not discussed the Atkinson-Shiffrin model, very quickly we will look into it. The Atkinson-Shiffrin model is very similar to the model which is called the modal memory model. And so, what Atkinson and Shiffrin says is that memory is a 3-part system. It starts with something called the sensory register, has something called the short term memory, and then is followed by something called the long term memory. So, these are what Atkinson and Shiffrin calls as the stores, the different stores, and that is why he says sensory store, the short term store and long term store. With these, additionally, Atkinson and Shiffrin also defines certain control on active processes which move information either from one store to another or move information out of these stores. And so, what Atkinson and Shiffrin model discusses is there is something called attention here, which makes information move from the short term register or the short term store to the STM, so short term memory, and from the short term memory information moves to the long term memory, depends on a process which is called rehearsal. So, this is how the items move from one store to another. Also, decay and interferences are two phenomena through which items move out of these two stores. So, decay interference happens in terms of long term memory as well as short term memory. And so, this is what a brief overview of attention and Schriffen model is. We will discuss this model in the long term memory. So, basically two positions to look at: interference and in terms of items in the middle of the list, or those items which people are familiar with. They showed higher amount of retrieval, or certain type of rules or certain type of remembrance which required the activity of the LTM. Those somehow went ahead and helped people in terms of remembering. So, with this conceptualization, another kind of store was perceived, or another kind of store was thought of, and that was called the working memory store. So, the information processing model of attention and Schriffen 68 described information processing as a two-part process: the information representations being stored either as STM or LTM, and the structure defining an STM and LTM store, and also the processes which is moving it. Now, these authors, they conceived of STM not as a store for 7 or few pieces of information for few seconds, but found that the information STM somehow activates relevant information from LTM and gathers some of this information into STS. So, this is what the conceptualization of the STS, or the short term store, or the attention and Schriffen model was. But then, as I described, these two problems led to the emergence of a new store, a new kind of memory system which was developed by Baddeley and H. Now, Baddeley and H 1974, they performed a series of experiments to test the model which was described above, which was attention and Schriffen model of how the STM works and what is the way in which STM moves information from itself onto the long term memory, or how it receives information from the short term store. Now, the design was to have participants temporarily store a number of digits while simultaneously performing another task, which is a reasoning or language task. So, two type of tasks were given to people, and as the STM store has 7 plus or minus 2 items, it was believed that if number of items are increased onto the short term store, some kind of interference or some kind of forgetting would happen, or the task would have a lower performance, poor performance. Now, the hypothesis was that STM capacity is taken up by stored digits, fewer resources are available for another task, and so performance on the task would suffer. As I just described to you, what happens is if two kind of tasks are given and one task is being stored onto the STS or the short term store, then what would happen is that the next task which is given to you, if it is a multidimensional task paradigm, and if a second task is given to you, the second task will not be processed, or if it will be processed, the performance will be very bad onto it. And so, this is the conceptualization on which Baddeley and H came up with a new dimension or a new kind of memory system, which was called the working memory system. Now, what was this task about? So, let us quickly look at the task that Baddeley and H came up with, the idea of Baddeley and H came up with. And so, what Baddeley and H task was called the reasoning task with a letter recall. So, what this task generally had is people had, first of all, they had to keep some letters, store a number of digits. So, a 6 digit or a 8 digit frame was what people had to store onto their memory. So, they had to remember this 6 digits. So, let us say the digits are 8, 2, 8, 6, 4, 3, 7. This kind of a setup was given, and people were asked to commit to memory this particular kind of a system which was there. And then later on they were given another kind of a logical decision making task. So, for example, here A, B, the letters A, B are presented to people. Now, what they were required to do while holding on to this 6 or 8 digit task into memory is basically tell as quickly as possible, verify the statements whether A precedes B, people had to say true or false, or whether B is preceded by A. So, this kind of a thing was given to people, and they had to keep these 8 or 6 digits onto their memory, and later on verify these statements. This A, B is given to people and then shown to people, and then they have to verify this A precedes B or B is preceded by A. What is the result of an experiment like this? Now, generally, or statement like B does not precede by A, this kind of a statement, true or false statement was given to people. Now, The interesting thing that happened here, the result of the experiment says that if the number of digits which were 2 to 3, if this is the number of digits which were held in memory, then the performance of people on the letter verification task, on the AB verification task, it was similar to what was there if no digit was given to them. So, two kind of people were there, or two groups of people were there. A control group had no digit to keep in mind or keep in the memory, and then do this sentence verification task or letter verification task, and in the next case people had 2 or 3 digits in their memory and were needed to do this kind of a verification task. Whereas, it was found out that if the number of digits that has to be kept in the memory was more than 6, then the performance went down. There was poor performance. So, if sentences also, some of the interesting thing was found out that if the sentence was negative, if a negative sentence was used for this kind of a thing. So, B does not precede by A. Look at this, this is a negative sentence. So, if a negative sentence or a passive sentence like this was used, now in this cases also the verification task was lower or the verification task was somehow less, but then a poor performance happened. So, basically then what happened is 1, 2, 3 items were preloaded, a reasoning task was done and a letter recall task was done. But in experiment 2, what happened is 0 to 6 items were given to people, a reasoning task was done and a letter recall task was done. So, this is the result of the experiment. What really happened? So, Baddeley and H, they found out that two codes which are different. One is the logical code, the other is the digit code. Now, if two codes are different, then with lesser number of items digits to be stored, the performance was not becoming poor or not hampered in any way. What does this suggest? It suggests that the way STM is conceived in the short term store, that if the number of digits are more, there will be poorer performances. That is not what's happening, which basically means that the short term store as conceived by Atkinson and Schriffen, that it is a store which holds on to similar kinds of 7 acoustic code in acoustic code form, similar kind of 7 plus or minus 2 items was not true. So, Baddeley and H in 1974 or Baddeley alone in 1991, they found out that there was no common system for cognitive processes. There was no common short term store which was prevalent or which was available for all kind of cognitive processes used in this. Also, the fact that memory load does not disrupt the performances. So, if lower memory load are given, if two tasks are there and if if one task requires some kind of a memory load or given little memory load, then the performance on the second task was not hindered in any way. And so, this is the result that we are looking at. So, reasoning times, in terms of reasoning times, letter recall, reasoning times, letter recall, in terms of the load was 0 and 6, and as you can see, what happens is if the load was more, the reasoning time and letter recall was higher than in terms of so it is equal stress. In this case, it is memory stress, and this is the kind of thing that happened. So, if the number of load was 1, 0, 1 and 2, and what do you see that the reasoning time was very less. It is nearly 3.31 second in which people were able to perform the reasoning task, but as it increased, the number of the time increased to almost 5 seconds for reasoning, which demonstrates two things, that parallel task processing can happen in the STM store as it was conceived by what Atkinson and Schriffen said. Also, the fact that STM store was not the way that it was conceived in Atkinson and Schriffen. So, STM was now a limited capacity store. The way it was looked at into Atkinson and Schriffen was no more limited capacity store. It had more capacities. It had capacities which is beyond which was sufficiently numerous, and then there are certain control processes which go ahead and move it. Also, the fact that way this STM is conceived onto, that it is a limited capacity, is no more true, that the capacity is more than 7 plus or minus 2, the way that is looked into. Also, if multiple tasks are given, people are able to complete this task, and interference that we talked about, that is not the reason, or could be, although it is a reason, but then if two different types of items are taken, then both can be processed, which gave the idea. Also, one more thing to be looked at here is that both the tasks require different kind of jobs. The A-B verification task require people to borrow from long term memory the rule for verification. For example, let us say this is A and B, and if there is a sentence, the sentence says that A precedes by B. Now, if this is the sentence, or the sentence says that B is preceded by A, or thinks that B is not A is not preceded by B. So, if A is not preceded, A is not preceded by B, if this is what you need to verify, or B is not succeeded by A, if this is the sentence that you have to verify, first of all this is a negative sentence, and then the words have a meaning, and the way that the verification happens is that these rules are actually stored into something called the long term memory. So, the long term memory has these rules stored up. So, what the conceptualization was, that these experiments for Baddeley and H, they gave up they brought to light three new important factors about STM. One, that STM can talk to long term memory, and can, at the time of processing itself, can borrow rules from long term memory, and that is how this verification really happens. The conceptualization of Atkinson and Schriffen was that STM is a store which basically keeps items and works and links them together through a control process, but on itself it does nothing to the item. Whereas Baddeley and H proved for the first time that there can be this kind of a sentence verification task, basically gave the plausibility or laid the foundations for the fact that more integrate or more complex verifications or more complex processes can be done onto this kind of tasks which were presented to people. Also, the fact that if items, different items, where first of all it is not the caustic code in which most items are stored into short term memory, it is different codes which are there, and so there are different stores within the short term memory is what the conceptualization was. And for the first time it was found out that this idea of limited capacity was not true. So, short term memory was not short of a limited capacity store. Other thing that interferences do happen, but then if items are of slightly different nature, then these interferences are not so prominent. If the items two tasks has little items to get interfered into, then interferences will not result. Also, the fact that at the time of the working memory execution, at the time of when item is into STM, with the control processes, there are other processes where LTM rules can be borrowed, and some kind of processes, some kind of operations can be done onto jobs put into this particular store. And so, a new conceptualization, a new idea of a store was thought of, and this idea or this store was what was the working memory store. And so, Baddeley and H gave the idea of this working memory store. Now, this is a very interesting conceptualization, because this till date this is the best conceptualization of short term memory which has been out there, and the best results have been approved of this. So, what is working memory then? Now, working memory as conceptualized by Baddeley and H is a three-part system. What happens is this itself, this whole part is now called as the short term store, although a new additional item is included here, which is called the episodic buffer, which I have not demonstrated here, but then this is the third system. So, it is basically a three-part store controlled by a central part. So, the conceptualization or the working memory is done in this way. Information from the short term store through attentional filters, attentional processes reaches something called the central executive. So, my working memory store is a three-part system. It has something called the central executive, it has something called the phonological loop, it has something called the visual sketch pad, and it has something called the episodic buffer. So, information which comes from the short term store through the attentional process in different modalities reach generally something called the central executive of the working memory. Now, what are the activities of this central executive? The activities are to initiate, control and decision process. The central executive can be thought of as a manager. It does not do anything. It takes in information from the short term store and then manages this information, or basically redistributes this information onto two sub stores which are there. And so, the two sub stores are the phonological loop or the articulatory rehearsal loop and the visual spatial sketchpad. Now, information which is verbal in nature, which is auditory in nature, are pushed on to the articulatory loop, articulatory rehearsal loop or the phonological loop. Whereas, information which is both spatial or spatial, I would say, in nature, or which requires visual medium, which is in terms of a visual medium, are pushed onto the visual spatial sketchpad. So, what basically an executive control system it does is takes in information from any medium and throws it into these two stores which are there. Let us look into one by one these stores. So, basically the executive control system or executive store is basically related to, or its activities are initiating, control and decision process. So, basically it initiates control, it distributes this information, different information coming from STS into these two stores. Also, reasoning, language and comprehension. So, basically if a task requires people to do reasoning or to basically go ahead and use language, then in those cases people, if reasoning or language is the requirement of a job, then in those cases what needs to be done is that the central executive comes into focus and then it does this job. How does this job of reasoning? What it tends to do is talks to the LTM through an episodic buffer. Now, as you know, then in attention shift model, the LTM is the store where most information is stored. Now, in the upcoming lectures, we will look into how the LTM is arranged, what is the way in which LTM is arranged and what is the way in which LTM really works. We will look into the parts of the LTM. But then most rules, facts or the things that we call memory are stored onto what is called the LTM. So, what this particular model does is that executive control, whenever it needs to do a task, it sends or it makes these reasoning language decisions based on rules which are borrowed from the LTM. For example, let us take a very simple task, the idea of being more. So, if a thing is more than something else, let us say if A has more number of, if there are 2 jars and this jar A has 4 items into it or 4 balls into it and jar B has 8 balls into it, and the concept of more. So, the question is whether jar A or jar B has more number of balls. If that is the question which needs to be verified, then the central executive does this verification by first taking this information, the information that there is a jar, there are number of balls, and pushes this information into the visual system. Then through the episodic buffer, it talks on to the long term memory and borrows the rule for what is more, the definition of what do you mean by more. So, what it does is it talks to long term memory, and the long term memory then reveals or relates back the idea of what is more onto the episodic buffer. The episodic buffer transfers this information to the central executive, which then understands what is more and then does the comparison. Also, it transfers information to long term memory by rehearsal and recoding. So, whatever answers that you get from this kind of control processes, this kind of rules which are borrowed from long term memory, and the information which is inputted through both the articulatory loop and the visual sketchpad, these informations when it makes any kind of meaning or if it needs to be stored through a process of rehearsal, it is transferred to a long term memory. For example, let us say if there is an event, you see your picture from the 4th or 5th class, and so you see a friend of yours, and now you know this friend is now married and does a job there. So, this information update, which is called recoding of information. So, the friend which is there with you in the 5th class, obviously at that point of time he doesn't has these features of getting married or having a particular kind of a job or doing a particular kind of a thing or looking in a different way. So, these informations are added up to this event and retransferred it back to LTM memory, so that LTM is updated onto these information. So, this is what also the central executive does, and effects like recency, primacy are also, which is verified by the central executive. Now, the central executive takes in auditory information and pushes out these information into the phonological loop. Now, the phonological loop has a idea of something called subvocal rehearsal. So, it does auditory rehearsal. As I said, the conceptualization of working memory is better than short term store, because the short term store only talks about auditory codes, but then working memory does not talk about auditory codes. It talks about both imaginal codes, which is image code, and auditory code. So, phonological loop that we are talking about has auditory code as the way of remembering things, and so information which is passed on from the STM is if it is in the auditory nature, it is pushed from the working memory onto the phonological loop, and then this item is rehearsed back, is remembered in terms of subvocal rehearsal. Also, this phonological loop has two different systems into it. One is called the phonological buffer, the other is called the subvocal rehearsal. Now, the phonological buffer keeps information ready for being accessed. Let us say I tell you the word Ram is going to the village. Now, Ram is going to the village, this sentence in an auditory code reaches your ear, it is passed on from the STM onto the working memory. The central executive listens to this one channel information, Ram is going to the village, and pushes it to the auditory loop or phonological loop. In the phonological loop, the buffer then breaks away this Ram is going to the village into its constituent parts. For example, what is the subject, what is the object, and what is the connector, what is the verb, and loops it. The subvocal rehearsal or subvocal rehearsal is the process where this whole sentence is looped because it is needed. If it is not needed, then it won't be looped, and so if it is needed, this kind of information is looped, and the buffer is the place where the information stays for some period of time. Also, recycling of items for immediate recall is done by this phonological buffer, and articulatory processes are done here. But if an item or if a piece of information which is approaching is not in the vocal dimension, if it is not vocal in any format, then what happens is that kind of information is then passed on to the visual spatial sketchpad. So, in the visual spatial sketchpad, the information is then broken down into its visual constituents, and so visual imagery, spatial image, visual search tasks are done by this visual search task. And so, here what happens is that the visual images are stored. Now, think about seeing a movie. How is it that we see a movie? When we go to a movie, there is a voice and there is an act which is happening. There is a sequence of acts which is happening. Here is the best example of understanding how the working memory happens. So, generally the audition or the auditory channel is a single channel process. For example, when I say Ram is going to the village, you have to listen to each word until and unless you come to know the meaning of the word, which basically means that Ram is going to the village has to be completely said or completely relayed back to you. If that is not done, then you will not understand the meaning of the word. So, basically then Ram is going to village, if I auditory present you, each word has to be presented to you, and so each word has a meaning, and so as words appear to the central executive, they are pushed onto the phonological loop, and the phonological loop then subvocally rehearses one after another. So, Ram is rehearsed after is, though Ram is now rehearsed with going, then Ram is going is rehearsed with to, Ram is going to is rehearsed with village, and so this is the kind of rehearsal, and then later on you can take an information. But and so that is why auditory channels or auditory systems are basically a single channel system. But if I show you this as a display, Ram is going to the village. Now, in one particular brief movement, you can look at the whole image and you can make meaning out of it. So, that basically means that visual systems are more accurate. Now, when you are in a movie, what happens is the dialogue comes as a one channel system, whereas the images that you see, the actions that you see is basically in terms of several sequences which are there. And so, there is where the best example of working memory is. What the central executive does, it takes in dialogues, because dialogues precede, and so these dialogues are taken in and then pushed onto the phonological loop, and then it is matched with the sequence of the action. So, the whole dialogue is taken in and is repeated around through the buffer and the subvocal rehearsal, and then later on a meaning is interpreted of the scene based on the auditory feedback, based on the dialogue and the action, and they are mashed together with the central executive. So, basically then both the information, the auditory and visual information in a movie are passed onto the store. The visual information goes onto sketchpad, visual informations are slower, it is basically stored down, and articulatory information are speeded up, and they are mashed together in real time for giving the meaning of what you hear, and that is where a good example is. Now, a third stage of this particular working memory is called the episodic buffer, and the job of this episodic buffer is basically to talk to the LTM. So, this episodic buffer basically does a feed forward and feedback connection with LTM. So, it takes an information to the LTM and takes that information also back from it. That is what the idea of this phonological buffer is all about. So, basically then an experiment was done to test the phonological loop, the existence of the phonological loop. And so, what happened in this experiment was what is the span or what is the capacity of this phonological loop. So, 3 sentences were given to people, they were read very fast, and so these sentences, so 3 kind of sentences, Ram is going to the village, Sita is doing something, and Ram is doing something. These 3 different sentences were given to people, and people were asked to relate back the last word. So, Ram is going to the village, so you have to relate back the word, you have to remember the word village back, or tell me the word village back. So, 3 sentences are given to people and they have to remember back the sentences. So, what was found out in this task? It was found out that this span, the phonological loop, the efficiency of the phonological loop or the span of the phonological loop depends both on the comprehension and the task complexity. The kind of task, if the sentences are very simple, it is easier for people to remember back the words. If the sentences are long and complex in nature, or if people are not able to understand the sentence, if the sentence contains words which have difficult meaning, in those cases the central executive, additional input from central executive is required, then those tasks are not processed. And so, basically the recall or the span of this auditory loop depends on both the task complexity and the comprehension, the way a thing is understood or read back. Also, for visual information or visual sketchpad, similar experiment was done, and it was found out the complexity of the visual system describes the span. So, if it is a simple system which is there, which people have to look into, then it was easier for people to relate back the information, but then if the information was complex, then it was difficult for people to relate back the information. So, then what does the working memory consist of? So, as I said, it consists of a limited capacity workspace that can be divided between the storage and control processing, and in this term it is the central executive that we are talking about. This component directs the flow of information, choosing which information is to be operated on, when and how. As I said, it is like a manager. So, it takes in a lot of information and then decides what information goes where. Then there is something called the phonological loop, which is used to carry out subvocal rehearsal and maintain verbal material. So, this is what we are talking about in terms of vocal, and the visual spatial sketchpad, which is that part of the working memory which takes in information from the visual area. Now, a very interesting study was done to comprehend the idea of STM, and that was with something called stimulus independent thought, the SIT. Now, the study was done by Tesdale in 1995, and so what was the study? The study was done to find out what factors or what stores of the working memory produces interference with stimulus independent thought. Now, what is stimulus independent thought? Let us first look into it. And so, stimulus independent thought, as it is defined, is basically a flow of thoughts or images that the content of which is unrelated to the immediate sensory input. So, basically it is kind of a daydream. So, basically stimulus independent thought is a thought, or is a kind of a thought process which is not related to the job at hand, to the task at hand. So, the thing was, the task was to find out if STM disrupts by performing another task. If people do another task of short term nature, if people are doing some task which is basically of some nature, whether it is visual and phonological in nature, whether stimulus independent thought are affected by it in some way or not, and that is what task was. So, two type of tasks were loaded onto the central executive. One task was to verify silly sentences. So, sentences like you can buy priests in shops, or a dog was raised on a flagpole. That kind of sentences were there, and so you have to verify these sentences whether this is possible or not. And another kind of task that were used was more of a looking task. So, in this some kind of a simple and complex a field was given, and within this field people had to find out known geometrical figures, for example triangles and circles. So, this kind of tasks were given. As you can see, this task is a phonological tube task, and this is a visual sketchpad task. So, visual task and phonological task, this type of tasks were given to people, and then people were asked to get engaged in something called stimulus independent thought, or basically go ahead and daydream. So, in sessions participations, so people then did this task, and with that they also daydreamed. And so, what happened is that at several points of time, so at several points of time people were basically stopped. So, this is how they are looking at, this is the stimulus independent thought, and they are also doing some other job. So, these tasks are loaded here, and so at several points of time, this is the time dimension. So, they are stopped here, and they are asked to relate as what is going on through their mind. So, they have to describe their daydream. So, the task is very simple in nature. Somebody is asked to daydream, and with that daydreaming they are also given two more tasks, either to verify a silly sentences which had no meaning at all, whether it can exist or not, and then also to do a looking task, which is basically equivalent to looking at something, looking at a simple field or a complex field, and find out hidden geometrical figures onto it. So, basically then, and in this particular the framework, people were stopped at various points of time. Since they are also daydreaming, they are asked to relate back what is it that they are dreaming, or what is it that they are thinking about. So, response categorizations of SIT of task, it was found out that basically neither the visual task or this kind of a thing, both the tasks together went ahead and interfered this stimulus independent thought. So, if kind of extra task doing was done, if people were doing some either sentence verification task which is phonological in nature, or a simple looking task which is basically visual in nature, this interfered with the stimulus independent thought, which basically means that SITs are something which are not independent of this kind of a loop. So, if a stimulus independent thought, if people are daydreaming and they are also given another kind of task which is to be done, then it did interfere with the stimulus independent thought. So, it's basically then what was the result of this study, that basically central executive is the reason why this kind of a disruption happened. Also, it was a version of this task was done in which people were able to do tasks with the stimulus independence. So, people were asked to daydream, and with this daydream they were asked to do some kind of a routine task which they always did. Now, in those cases when people did routine tasks and they daydream, then the performance on daydream, the performance on relating back daydream was not that poor than in cases where people were loaded up with tasks, or people were asked to do tasks which required some part of either the phonological loop or the visual sketchpad. So, basically then it is not these centers or these areas of the working memory identification or working memory system which is responsible for disrupting the stimulus independent thought, it is the central executive. So, when a task has been well practiced, routine in nature, then the central executive can devote enough attention and stimulus independent thought can process. But when a task requires some kind of information processing, some kind of jobs to be done, or some kind of matter to be looked at, some kind of verification which requires some kind of an effort, in those cases this stimulus independent thoughts got receded onto. So, basically in this particular section what we looked into is two things. So, breaking up from the last section or thinking from the last section where we looked at what is short term memory and what are the codes of short term memory, how it is stored, what is the conceptualization, what is the test for short term memory, and what is the kind of forgetting happens. In this particular section we devoted ourselves onto a new conceptualization of short term memory, which is the idea of working memory, and we also looked at how this working memory is tested, and then what is the different parts of working memory and what is the benefit of using the working memory model over the short term memory model. So, one obvious benefit is that the use of working memory does not limit ourselves to limited capacities first of all, then it does not basically bound us onto the concept of limited time processing. Plus, it says that the kind of coding that is done, working memory model of short term store does not limit us to a particular kind of code which should be used for remembering. So, that is another benefit which is there. Plus, the fact that working model or working memory model allows us to think about a conceptualization of a store in which the store can talk to LTM and can get informations. And so, the explanation of the serial position curve, that items which are familiar appeal to you more, and so the central executive what it does is, if an item appeals to you more, if it relates to you in some way, if the relativeness is very high, it is immediately transferred onto the long term memory, or it is immediately verified, because this item is already present in the long term memory. And so, the conceptualization or the question that came in from the results of the serial position curve, that items in the middle of the list which were familiar or which were somewhere personal to people, how they were remembered more, that could be explained through this model of working memory. So, then working memory model is a better model of short term store or the short term conceptualization. And so, in this whole 3-part lecture on memory, introduction to memory, we saw how this memory system really works. We looked at the short term store, the basic formats of the short term store, of how what happens and how things happen. We looked at something called the short term store, or what is the capacity of the short term store, what it does and what it does not, and what kind of information is stored, and also into the working memory, which is a better conceptualization of the short term store, what are its part, what is the feedback it takes in, how does it connect to the long term store, and what are the benefits of the working memory store over to the short term store. So, in the next coming lecture, we will look into something called the long term store or the long term memory. We will look into the various parts of the long term memory, and then in upcoming lectures, we will also look into parts of or different conceptualizations of working memory. Thank you.